Okay, 1543. We have a 20-gram bullet traveling at 400 meters per second. When it becomes embedded in the 2-kilogram stationary block. The question is, determine the distance the block will slide before it stops. Okay, so it's initially stationary. The bullet hits it, becomes embedded inside the block, and transfers this energy into the block, and the block and the bullet begin to move, and then the block and the bullet come to rest. Okay, it stops. And why would it stop? Because there is kinetic friction with a coefficient of 0.2. Okay, so let's just analyze kind of just what is happening. The first thing is the bullet and the block are separate, and the bullet hits the block and becomes embedded. Okay, and then both of them start moving with a, so there, say there's the bullet, so the bullet becomes embedded and they immediately start moving with a velocity. That's our first analysis. Then our second analysis is it starts moving with this velocity and then comes to rest where v equals 0. And there's the bullet. Okay, so there's analysis 1. So we first need to determine what this velocity is right after it becomes embedded. That's analysis 1. Analysis 2 is, what is this distance that this travels? After the bullet gets embedded, it starts moving at this velocity, and then because of friction, it slows down until the velocity is 0, and we want to know what is this distance traveled. Okay, so because, if that is my system, because they interact with each other, the two particles, we know we can apply conservation of momentum. So let me just get my cheat sheet. Okay, so the first thing is mass of bullet, velocity of bullet, plus mass. Okay, that's not going to work. They're both B's. Okay, how about small b is bullet and big B is block. At state 1 is equal to, now the mass of bullet plus mass of block times velocity 2. Does that make sense? So they're separate at state 1. The momentum of the bullet plus the momentum of the block at state 1 equals the momentum at state 2, but because this gets embedded, they become one mass, and they're both traveling at the same velocity. Okay, let's call this just v. Alright, so the mass here is 0.02, that's the mass of the bullet, times 400 plus 0, because the velocity of the block is 0, is then equal to 0.02 plus 2 kilograms. Okay, there's the total mass times v. And if you solve for v, we get 3.96 meters per second. Okay, so that's the first thing that we needed to do, is we needed to find this velocity that the block and the bullet start moving just after impact. Okay, so there was our analysis 1. Okay, now analysis 2. Now let's see, why does this block slow down? Well, if we draw a free body diagram, the only force in the horizontal direction is kinetic friction acting in the opposite direction. We've also got a normal force and we've got weight acting down. There's our free body diagram. Okay, and there's our bullet inside the block. So we're trying to find this distance traveled. Okay, so if we look in the x direction and say we take right as positive, then we're going to have the total mass of this entire system times the velocity, which is this velocity here, and we're going to have minus friction, the friction force dt, which is the negative impulse due to the friction, equals 0. It's going to equal 0 because our final velocity is 0. So we can see that this friction force, we know that the friction force is equal to mu k n, alright? So we need to find the normal force, and that's straightforward. N minus weight is 0, and you can solve for the normal force, which is 8162 Newton. Okay, so that's the normal force. We've got our mu k equal to 0.2, so we can put that in here. So the total mass is 2.02 times 3.96 minus 0.2, because these are all constants, we can take them out of the integral, minus 0.2, that's my mu k, times the normal force, which is 19.18, times time. Okay, because we've integrated the dt, and we're going to get t out there. Okay, and then that is equal to 0. It's equal to 0. Let's see, 2.02 times velocity. Okay, sorry, this should have been 2.02 times v. Okay, now the reason why we did this is because we want v, the final velocity. I know, okay, I made a mistake here. I should have put the 2.02 v here, times velocity. And the reason why we want it in terms of v is because we want v as a function of time. And we'll see why in a minute. We know that the final velocity is 0. That's true. But we first want v as a function of time. Okay? So if you rearrange this, you're going to get this. 3.9604 minus 1.962 time, okay, meters per second. So we've got v as a function of time. Okay, now at state 2 we know that v is 0, so if we put a 0 in here, we will find, so at v equals 0, time is equal to 2.01 seconds. 2.01 seconds. Alright? But that's not what we're after. We're after the total distance. So the reason why we wanted v as a function of time is so that we can now apply kinematics, where we say v is ds dt, and the v we know is 3.9604 minus 1.962 t, and so ds then is the integral of ds is the integral of 3.9604 minus 1.962 t dt between 0 and t, between 0 and s, and we get this function again. Remember guys, we want these functions. This is 3.96 t minus 0.981 t squared, and we put this time in this 2.01, we put that in there, and we get our total distance, which is roughly 3.99 meters or 4 meters. Okay? Alright, I hope this helps. So you had to tie a few different things in there. Okay, cheers.